These are two continents separated by just 13 kilometers of water, yet no bridge connects them. This is the story of why Europe and Africa remain unlinked at the Strait of Gibraltar, despite over 150 years of proposals and engineering dreams. Picture this narrow stretch of water between Spain and Morocco. At its closest point, you could drive across in under 10 minutes, if a bridge existed. Every year, 5 million people and over 1 million vehicles cross by ferry, while 100,000 ships navigate these waters carrying $700 billion worth of goods. The demand is clearly there. The distance is manageable. So why hasn't anyone built this bridge? The answer begins 300 meters below the surface. That's the minimum depth of the Strait of Gibraltar, about as tall as the Eiffel Tower. But it gets worse. In some areas, the seafloor plunges to 900 meters. To put that in perspective, the world's current tallest bridge pier stands at 343 meters. Building foundations at Gibraltar's depths would require engineering that simply doesn't exist yet. But depth is just the beginning of the challenges. The strait is where the Atlantic Ocean meets the Mediterranean Sea, creating a unique and violent water exchange. Every second, 1.5 million cubic meters of water flow through this narrow gap. That's not just a current. It's a massive perpetual water exchange with surface Atlantic water flowing east while deep Mediterranean water flows west. These opposing currents create forces that would constantly push and pull at any bridge structure. The first person to formally propose bridging this gap was a French engineer in 1869. Since then, the idea has captured imaginations and frustrated engineers for over a century and a half. In the 1930s, Spanish engineer Alfonso Pena-Boeuf drafted ambitious designs. By 1979, Spain and Morocco formed a joint commission to seriously study the possibility. They brought in experts, conducted surveys, and crunched numbers. Then, in 1985, something remarkable happened. T.Y. Lin, one of the world's most renowned bridge engineers, presented a suspension bridge design that seemed to solve many of the technical challenges. His proposal featured towers standing on relatively shallow underwater plateaus, with the main span suspended high enough for ships to pass beneath. For a moment, it looked like the dream might become reality. But the numbers told a different story. Cost estimates ranged from $15 to $20 billion, and that was just for construction. The maintenance costs for a structure battered by winds that can exceed 80 kilometers per hour in one of the world's busiest shipping lanes would be astronomical. José Antonio Fernández Ordóñez from the Spanish Academy of Engineering summed it up perfectly. The depth and the strong currents make this one of the most difficult maritime crossings to bridge. By 1996, detailed engineering studies revealed even more challenges. The region is seismically active. Earthquakes could potentially damage or destroy a bridge, with catastrophic consequences for both human life and the global shipping that depends on this passage. The Spanish Society of Civil Engineers presented their findings with a sobering conclusion. While technically possible, the risks might outweigh the benefits. So in 2003, the focus shifted. If we can't go over the water, what about going under it? Morocco and Spain agreed to study an undersea tunnel, similar to the Channel Tunnel between England and France. On paper, this seemed to solve many problems. No weather concerns, no ship collisions, no interference with the critical shipping lane. But the Gibraltar Tunnel would face its own unique challenges. Tunnel engineer Giovanni Lombardi, whose Swiss firm studied the project, stated bluntly, "The Strait of Gibraltar is one of the most challenging places in the world to build a bridge." That assessment applies equally to tunnels. The geology is complex, with different rock types and fault lines. The depth means extreme water pressure, and that powerful water exchange between the Atlantic and Mediterranean. It happens below the surface too. By 2009, studies continued with EU funding support. Engineers proposed a rail tunnel that would run about 40 kilometers total, connecting to points where the underwater distance could be minimized. But progress remained glacial. In 2014, technical studies were still ongoing. By 2018, Political tensions between Spain and Morocco had cooled enthusiasm for the project. Throughout all these proposals and studies, one factor remained constant: the ferries. 5 million passengers cross every year, along with 1 million vehicles. For ferry operators, the status quo works perfectly. They've invested in larger, faster vessels. The crossing takes about an hour, and while it's not as convenient as a bridge, it functions. Any fixed link would devastate their business model, so there's significant lobbying against bridge or tunnel construction. But perhaps the most overlooked challenges aren't engineering or economic, they're political and social. A European infrastructure analyst noted in 2020, "It's not just an engineering challenge, it's a geopolitical puzzle." Consider what a fixed link would mean. Right now, the strait acts as a controllable barrier. Morocco and Spain can regulate who crosses through passport controls at ports. A bridge or tunnel would create new challenges for managing migration between Africa and Europe. It would affect Gibraltar's unique status as a British territory. It would create security concerns about controlling access to such a critical piece of infrastructure. Environmental concerns add another layer of complexity. The strait isn't just a body of water, it's a unique ecosystem. This is where killer whales hunt tuna in spectacular displays. It's a critical flyway for migrating birds traveling between continents. The water exchange between the Atlantic and Mediterranean affects marine life throughout both bodies of water. Any construction would need to account for these environmental impacts. Some environmentalists argue that the current ferry system, while not perfect, creates less permanent disruption than a fixed structure. Construction alone would take years, potentially affecting protected areas on both coasts. And once built, a bridge's pillars or a tunnel's ventilation systems could permanently alter water flow patterns. The ancient Greeks called this place the Pillars of Hercules, the Rock of Gibraltar in Europe, and Jebel Musa in Africa. To them, this was the edge of the known world, a barrier not meant to be crossed. In some ways, their mythology has proven prophetic. As of 2024, the project remains in the study phase, where it's been for decades. Morocco is investing heavily in port infrastructure instead. Spain is extending its high-speed rail to southern ports to improve connections to existing ferry services. New, larger ferries with greater capacity enter service regularly. The two continents remain 13 kilometers apart, connected by ships rather than concrete and steel, but the dream persists. Engineers continue to refine designs. Politicians occasionally revive discussions. The joint study organizations, Spain's SESEGSA and Morocco's SNED, still exist, still studying, still calculating. Climate change adds new variables to consider: rising sea levels, changing storm patterns, evolving environmental priorities. Some proposals now include renewable energy generation integrated into any future structure. Imagine a bridge that not only connects continents, but also harnesses the powerful currents and winds to generate clean electricity. It's an appealing vision, but it adds yet another layer of complexity to an already seemingly impossible project. The question isn't really whether we can build a bridge between Europe and Africa. With enough money, determination, and engineering innovation, humans have proven capable of incredible feats. The question is whether we should, whether the benefits outweigh the costs, whether the dream is worth the reality. For now, the Strait of Gibraltar remains what it has been for millennia: a barrier and a connection, a divide and a link. Ships continue to cross as they have since ancient times, carrying people and goods between worlds that remain tantalizingly close, yet fundamentally separate. The 13 kilometers of water that could be bridged in minutes by car continues to require an hour by ferry. Perhaps one day, future generations will look back at our time and wonder why we didn't build that bridge, just as we look back at the engineer in 1869 who first proposed it. Or perhaps they'll thank us for preserving one of the world's last great natural barriers, understanding something we're still debating, that not every gap needs to be bridged, not every challenge needs to be conquered. Until that future arrives, Europe and Africa will remain as they are, two continents, two worlds, separated by one of the narrowest yet most significant stretches of water on Earth. The bridge exists only in proposals and plans, dreams and designs, waiting for a future that may or may not come.